let's say you are having a medium scale industry, okay, but still you want to build a data warehouse system. Okay, you spend a lot of money and build a data warehouse system. So once you build the data warehouse system, see why we are using data warehouse system, especially to
To
analyze
handle
your,
lot of data.
yeah, handling the lot of data and then analyze the historical data, and you are gonna higher management gonna have a critical decisions to take the critical decisions so that they can generate more revenue in future. So it's simple. So they want to generate more revenue. They want to analyze the data so that they can take critical decisions faster manner. So that by taking those critical decisions, they can generate more revenue in future. Right. So let's say medium scale industry built a data warehouse system, and they handled all the historical 30 years of the data. But if the organization is unable to utilize data warehouse system, is unable to analyze the data to make some critical decisions to generate more revenue, so it doesn't make any sense, right? So that's the organization should have a necessity of data warehouse system, and also the organization should be able to utilize the data warehouse system properly. Okay, so only such organizations can go for data warehouse systems. Right? You understand, right, Malika?
Yeah, I do. Yep.
Okay. And so I was telling you, like, I mean, the data warehouse systems, whatever we are designing, right? So we generally follow the dimensional modeling. So we won't follow relational modeling. So what are all the different key concepts of dimension? See, Malika, I mean, you are into testing background or development?
I am like I was in. Sorry, you're talking about before or now?
No.
Oh,
I
okay.
mean,
Now, like I want to go into the development, like not the testing.
okay, that's fine. So here, dimensional modeling key concepts. So these key concepts probably might not be, you might not be using these key concepts. Generally, architects and whoever builds the schemas, so those people generally need this. But still, these all concepts will help us to understand the data warehouse systems very better manner, and also to if you want to attend interviews, so these concepts are very important for us. Okay. And dimensional modeling key concepts. So that dimensional modeling is a business process centric. So what does it mean? So whenever we build a data warehouse, we generally follow dimensional modeling. So this particular dimensional modeling is a business process centric. That means, let's assume a retail industry, Safeway or Walmart. Okay, so what is their business? So their business is to sell the products, right? So that is their main business. They want to sell the products whatever they introduce, right? So that means, so while building a dimensional model, while building a data warehouse using dimensional modeling, so you need to we need to mainly concentrate on the business, what we are handling, what we are dealing with. If you are building a data warehouse system for retail industry, their business is selling the product, sales related data. So that way, so while building any any data warehouse system using dimensional modeling, we generally concentrate more on business process. Okay. And so generally it deals with large amount of data, this we already know. And there is another concept called data marts. Okay. So data mart nothing but, so if we combine multiple data marts, okay, I'm going to show you what is data mart in the further slides. Okay. So whenever you combine multiple data marts, I can say it's a data mart is a subset of data warehouse. If we combine multiple data marts, which forms a data warehouse. Okay, it's a subset. Data mart is a subset of data warehouse, and if you combine the multiple data mart, which forms your data warehouse system. Okay, and there are another two key concepts, okay, in dimensional modeling. One is fact table and dimensional tables. Okay, these two are very important for us. So what is fact table? Okay, so fact table generally corresponds to a business process. Okay, so that means, see, I mean, in generally in relational modeling, we generally talk about normalization 1, normalization 2, normalization 3, if you remember, right? So we generally follow the relational model, and where we be talking about normalization process. Right here, in the same way, here we generally talks about fact tables and dimensional tables. Okay, so whenever you build data warehouse using dimensional modeling, two main concepts are fact table and dimensional table. So what is fact table? So when we consider the fact table, so fact table generally corresponds to a business process. So as I told you, if you consider the retail industry, Walmart, so what is their business? Their business is selling the products. That means the sales related data will be stored under your fact table. Okay, because the fact table is corresponds to a business process. The business process for the retail industry is a sales. Okay, so the sales related data we will be storing under fact table. Okay, and another thing is, generally the fact tables contains the data related to the numbers. Okay, numbers means it contains a figures and facts and figures and numbers. Okay, so sales related data is one example, so which will be having like total $3,000 of sales, right? That is numbers, so facts. Okay, right? You understand, right, Malika?
Yep, go ahead.
And then dimensional tables. So what is dimensional table? So generally dimensional tables that contains the information about the different attribute properties of your business process. So as I told you, the Walmart business is selling the data. So to sell the data, right, sorry, selling the products. So to sell the products, so there are different attribute properties which will be involved in any business process. Okay, so the attributes whatever involved in selling the products, so those attribute properties will be stored under dimensional tables. So in the fact table we are storing facts, we are storing the actual business process related data. If you consider retail industry, we are storing the sales related data in fact tables. And what about dimensional tables? The different attribute properties which involved in your sales. Okay, that particular data will be storing in dimensional tables. Their sales related data. Here the other properties which involved in your sales, those properties related data will be storing under dimensional tables. Okay, so what are all those properties? Let me explain what are all the different properties which involved in your business process. Okay, so let me explain. So to sell the products, so what are all the different attribute properties that are involved in business process called selling? So let's say you have stores. Generally to sell the products, you need to build the stores, right? So Walmart is having different stores. Store 1, store 2, store 3, you will be having different stores in a single city and also in different cities, right? That is one attribute property. And you will be having customer types. Probably you will be having permanent customers or premium customers or normal regular customers. So different customer types also one kind of attribute property, and also the product types. you will be having n number of products, right? Some products probably generating more revenue, some products probably generating lesser revenue, some products are frequently purchased by the customers. So all these, as I told you, different types of customers, different types of stores, and then different types of products. So these are all the different attribute properties which involved in sales, right? So that means stores, all these attribute properties will be stored under dimensional tables. So see here, we generally, let's say one example I'm going to tell you. I'm going to track the business process. Generally, what is the business process which we follow? The process which we follow in retail industry. Generally, buyer goes to a particular store. He has to select the store, which store he wants to go, right? And then once he enters to the store, he chooses a product from different aisles. You will be having aisles, right, in your store. So you need to select a product from a particular aisle, correct? And then once you choose the product from a particular aisle, he has to go to counter, and then he has to go to receptionist, and then he has to pay the money probably by using credit card or your cash or whatever it may be. So once you purchase your product, probably you may keep it with you or you return it. Okay, so whatever the letters which I have bolded here, different types of customers, buyers, okay, stores, products, counters, and payment methods. Okay, so these are all the different attribute properties which we are going to store. These are all the dimensional properties. Okay, so these dimensions, attribute properties, will be stored under your dimensional tables, and the sales related data will be stored under fact table. Okay, so any questions before I move forward?
No question.
Okay.
Go ahead. It's good.
Yeah.
Yep.
So here, so now if you see, this is one of the schema model. Okay, so to build a data warehouse system, first we need to design a schema, right? So this is one kind of schema model which is called a star schema. If you observe here, the table, database table in middle, the sales, right? So the sales related data is stored under this particular table, right? So this is called a fact table. If you observe closely, this fact table contains what? Units sold, dollars cost. So here we are totally talking about the data related to sales is stored under your fact table. Okay. And what about rest of the tables? If you see here, you have only product code, description, what is the color of your product and size of the product. So that means here if you observe, this fact table contains numbers, right? All the numbers. There is no textual representation. Problem you might be having, but most of the times you will be having only numbers. If you see here, the dimensional table, these are all different dimensional tables. The product code, description, color and size. There are no numbers. That's totally talking about textual data, correct? So the product type, and then stores, store code, store name, city, telephone, manager. So these are all the different dimensional tables, okay, where we are storing simply the different attribute properties like stores, products, and the what is the period code, year, quarter, month and date, right? And the fact table contains all the facts, numbers, figures. Okay, so this is star schema. Why? See here, all the dimensional tables are directly related to your fact table. These dimensional tables are directly connected to your fact table, right? So if you have another dimensional table here, it also going to directly connect to your fact table. So one to many or many to one, many, whatever the relation it may be, the dimensional table should be directly connecting to your fact table. So this kind of schema model is called as star. So it's represents star, right? star schema. Okay, so I mean, while designing the data warehouse using dimensional modeling, you have to build these schemas. Okay, if you combine multiple schemas, okay, this is one schema, and you build one more schema, and you will combine these schemas, it forms a data mart. Okay.
Okay, so it's like a single. So there can be multiple schemas in a single data mart.
Exactly. And then
Okay.
once you
Okay.
combine these multiple schemas which forms data mart, and the data mart, of course in data warehouse there might be only one single data mart, generally it won't happen, and the data marts, if you form a multiple data marts, okay, that data mart, multiple data marts called as a data warehouse, that forms a data warehouse.
Yes, yes, yeah, true, that's true.
Okay, now, so while building any data warehouse using dimensional model, you may have to follow star schema model. So again, that depends again on the organization and business. Okay, there is another model which is called a snowflake schema model. Okay, if you observe here, so this is your fact table where we are talking about only sales, price, units and dollars, and this is store. I'm talking about the store and which city of the store, what is the district ID and what is the region ID, etc. And this is your district dimensional table, and this is your regional dimensional table. So in this snowflake schema model, the store dimensional table is directly connecting to your fact table, whereas the other dimensional tables, district ID and the region and district dimensional tables are not directly connected to your database, fact table, but indirectly it is connecting to your fact table. So that's why this is called as a snowflake schema model. So which schema you want to follow, that depends on your business and that depends on the analysts. Okay.
Okay.
Database system.
Okay. Ravi, I have one doubt. Like previously I had an interview and I was asked this question, like which project did you use and what kind of schema you used? Like he asked, did you work on, it shows that you worked on star schema. So can you please explain? So that's what he asked. I do have an idea of about star and snowflake schema. That's only theoretical. But so he was asking how I actually performed in a project using this schema, using the star schema. Yep.
So
and now I understood. Yep, I got it.
So probably you may need to answer him like, I worked on, let's say you worked on sales related, retail industry. Data. So generally in our star schema, most of the sales related data will be stored under sales underscore Walmart. That is my database table, which I'm storing all the sales related data. Okay. So while loading data from your production, so let's say in production, the database, what I'm talking, OLTP, the source system. In source system, the database tables are not structured properly in this way, right? Okay. So they won't follow the same manner. Okay. So probably sales related data might be sitting in multiple tables in your source system. Okay. So you might be extracting this sales related data from multiple database tables and loading into your single database called sales, right? Okay, and star schema especially talks about, that's what so you need to retrieve the data from your source data, the product related, all the product related data should be sitting under your product table in your data warehouse system. But whereas in your production system, this product related data might not be sitting under one single table, right? Okay, so that's what. So while loading the data in star schema, all the sales related data I'm separating into one single table called sales and different attribute properties. So because you see in OLTP, so the data structure, data schema structure is not same as is. It's totally different because we are in OLTP source systems. We are more concentrating on the daily transactions, correct? Daily transactions should be very faster. We are building a database. We are designing a database in such a manner the transactions are very faster. Any add, addition, deletion, and modification of the data should happen very faster, right? And it should handle the live data. But whereas in data warehouse, I'm designing the data in such a manner. This is one star schema where I'm using all these, all the sales related data I'm storing in one table and one attribute property called product. So if I want to retrieve the data, because why we are doing this way? See, if I want to retrieve a data, related to revenue, which is generated for a product called X, for example. So it's very easy, right? I'm simply connecting the primary key of product code with the foreign key of my product table, right? So let's say the product code here, you can see the connectivity, right? Product code and product code, primary key and your foreign key of product code from the product table. If I want to retrieve the, what is the revenue which is generated from the product called X? See here, if I perform select query by combining these two tables, I can easily get the data. Simple. And if I want to generate the revenue which is generated on so and so day, okay, from the store which is having from the store from the city Florida, for example. So see here, store code is connected with the foreign key. This is primary key, foreign key, right? And the period. Let's say I want to retrieve the data of 2003. So simply I can perform a select query because the database is designed in such a manner. I'm making connection with store code and the period, right? You understand, right?
Yes, yes.
That is the way you are gonna retrieve the data. Okay, and Snowflake schema. So see, of course I'm going to tell you some examples also once we, probably in further classes.
Sure.
How are we gonna retrieve the data? Because as I was telling you, the design, the database design schema model is not at all same in your source system compared to your database.
Okay. Yep.
So what kind of different transformations? Let's say, as I told you here, the sales related data in your production, in your source system, the sales related data will be in multiple tables. Okay, but whereas in data warehouse system, I'm storing all this sales related data into one single system, single table. So how can I retrieve the data of sales related data from multiple tables and load it into your sales table? So you will be performing some transformation. So Informatica supports 20 to 25 different types of transformations. Okay, so I want to retrieve the data from multiple tables and load it into one single table. So there is one transformation we'll be using for such kind of things. Okay, if I want to retrieve the data from single table and load the data into multiple tables, so we are going to use another transformation. Okay, so all these kind of different transformations we are going to use to make sure I'm loading the data into my data warehouse system, because the database design is totally different. Okay.
Yes. Are you talking about the data warehouse design or the,
Yeah, data warehouse design.
Yeah, I got it. So it's like the schema in the source system it's different from the data warehouse system design.
Exactly, right.
Yeah,
because
I got it.
If you have a same schemas, there is no concept of transformation. Simply extract and load it.
Yeah,
So
yeah, I got it.
concept of transformations. Like I mean, probably why we need transform, because I mean, the first of all, the design itself in data warehouse system, because the purpose is different. So your source system purpose is handling live data, handling end user operations, right? But the data warehouse system purpose is what? Just to analyze the data. You are using mostly select queries. That's it. I'm not going to perform daily addition of the new records and deletion of the records and modification of the records. You are not going to modify the data, right? You simply retrieve the data to analyze the data, right?
Okay.
So that's why the design is different. What we follow in data warehouse compared to your source system.
Yeah.
Right?
Yeah.
So that's why you need to perform a lot of transformations. You have to convert your data into your historical format system. That's all.
Okay, I got it. I got it. And one more thing, Ravi, like, so is it like in star schema and snowflake schema, is it like one-to-many, the whatever, like?
It's just not only one-to-many. Probably, I mean, it is one-to-one or it is one-to-many, many-to-one. One. It depends. Depends on your.
It depends. Okay, depends
Yeah.
upon requirement. Okay, I got it.
But there is no concept called normalization here in data warehouse. Okay.
Yeah, yeah, I got it. Yes.
Only fact and dimension. Separate your the tables in the two different models: fact table and dimension table. Simple.
Okay.
Right?
Yes, yes, I got it. Go ahead. Yeah.
So probably, I mean, here, so in the next classes, I'm going to tell you, because see, I'm talking fact table, but what
Yes,
kind
yes.
of data I need to put into fact table, okay, and then what are all the different types of fact tables we generally consider, and then what are all the dimension tables we generally consider. See, because you see, so whenever you build your schema, it's not very easy for us to build schema. Okay, so you need to identify different types of fact tables, and you have to know about the dimensions, and then different types of dimension tables, okay, to design your schemas. Okay, so in next classes I'm going to cover major types. I mean, many types of fact tables are there. Major types of fact tables I'm going to cover, and major types of dimension tables I'm going to cover. But one thing is, these are all the architects generally design your schemas. Okay.
Okay, okay. Sure, sure. Ravi, one more thing, like, do you have the video for the previous class?
So yeah. We do share the recorded sessions. Probably today's and yesterday's recording session I'm going to send you.
Yeah, sure. Like I have an habit of writing on Notepad, and I lost that note. So I don't know where I saved it. So
Okay.
I just want to go through that. I do have a clear picture of what happened day before yesterday, but yeah, I just want to practice on that. And thanks so much. Yeah.
Sure. So from today onwards, what we'll do, probably like, I mean, tomorrow's session, before I begin tomorrow's session, yesterday's recording will send you. Okay. And in the same earliest recording. So I'll be sending these two. I mean, we will be sending, Srini will be sending these two recordings to you.
Okay, okay, sure. And one more thing is, like, do you want me to practice anything on SQL? Because regarding
basic, you have a basic idea on queries?
Yes.
That is enough. So while doing our practical sessions on Informatica, so the basic queries are needed, because see, the Informatica itself. So if you are not using tool, okay, for ETL processing, probably you may need the expertise in your queries, database system queries.
Yes.
You need to write procedures, you need to write different kind of procedures to perform ETL, but the tool replaces everything. So you need not to write the complex queries, because those
already the databases are already there. The just thing is, like, you need basic queries to extract them. That's it.
Exactly.
Like extract for it. I got it. No,
Mapping, whatever the mapping we are going to create, right? that
Yeah.
itself
Yes.
is
Yes.
complex to me. Simple.
Yes.
Okay.
Yep. I got it. I got it. Sure.
Yeah.
Yeah.
Okay.
Thanks, Ravi.
Okay.
Thank you so much.
So that is it for
Yeah.
today. So tomorrow, catch you
Okay.
tomorrow, same time.
Yeah.
Same time.
Sure. Sure. Yeah.
Yeah. Thanks.
Thanks, Ravi. Have a nice day.
Yeah.
Yeah.
Bye bye. You too.
Bye.